All right, and part 3 of 4.2, using all those crazy sum and difference formulas. So this one, we're being given two setups for alpha and beta. We're told alpha is between 0 and pi over 2, so that's a quadrant 1 triangle. So let's start there. And we're told that the sine of alpha is 3 over 5. So that puts a 3 here and a 5 here. And Pythagorean theorem super quick, 4. Because it's a Pythagorean triple, 3, 4, 5. All right, so let's go ahead and make sure to label our angle so we don't forget later. So we have the sine of alpha was 3/5. I'll go ahead and rewrite it. The cosine of alpha is 4/5. And they did ask us some tangent formulas, so the tangent of alpha is 3/4. All right, now our beta, they tell us is between pi and 3 pi over 2. So that is a quadrant 3 angle. So I'll put that up here, diagonal line, and then back to the x-axis. So there's our beta. The cosine is adjacent, -5 over hypotenuse, always positive, 13. This is also another Pythagorean triple. It's 5, 12, 13. So the length of that side is 12. The direction of that side is -y. So that is a -12. All right, so our sine of beta is -12/13. Cosine of beta is -5/13, like they told us. And the tangent of beta, opposite, so -12 over -5 will become positive 12/5. Cool. All right, so I have all my pieces. Now I just got to follow the formulas to put the pieces in the right spots. All right. Sorry. All right, so A, sine alpha to sine, cosine, cosine, sine. Now, I know it sounds silly, but it's actually beneficial to write the formulas every time because you write them enough, you know them, and you don't have to think about it anymore. So you can like write the whole thing, then you just look at the formula sheet real quick, like, yep, got it right, okay, and you can move on. You're not having to like look at the formula sheet 20 times to get each piece down. Sine stays, so this is a plus. All right, now we fill in. Sine of alpha is 3/5. Cosine of alpha is 4/5. Sine of beta was, cosine of beta was -5/13. Sine of beta was -12/13. And now we're just multiplying. So that is -15 over 65 plus -48 over 65. 3 carry a 1, -63 over 65. And strangely enough, that is lowest terms. So because our two triangles had sines and cosines, all the sides didn't have square roots, we can actually finish the calculation here and get it down to one fraction. Before, our fractions had like square root of 2 plus square root of 6 all over 4. Little uglier. All right. Now our cosine. So that is cosine, cosine, sine, sine. alpha, beta, alpha, beta. Cosine changes, so this will be a minus. So cosine of alpha 4/5, sine of alpha 3/5. Cosine of beta, -5/13. Sine of beta, -12/13. Then recopy the minus sign from the problem. So we have -20/65. And then minus negative, this will actually be plus 36/65, which is 16/65. So last ones are the tangent ones, which, like I said, I don't remember my tangent formulas, so let me write down what I do remember. I know it was the sum of them on top, and the sign stayed the same. And then one sign changed, and the product. Okay, so I guess I do remember more than I realized. But still, let me just double check. Plus, plus, minus. Yeah. And then I'm just going to sneak in here. There's the formula for a tangent of alpha minus beta. It's the same format, we just changed the signs. All right, so let's go ahead with C now, which was tangent of alpha plus beta. So tangent of alpha was 3/4. Plus tangent of beta was 12/5 over 1 minus 3/4 times 12/5. All right. So it's all fraction numbers. So as long as you very carefully type it, you could type this in the calculator, enter, answer, done. My calculator on my phone doesn't do fractions, so I am going to use a creative math trick. Common denominator on the bottom is 20. 4 and 5 both go into 20. So I'm going to use that to clear my fractions. 20 times 3/4 is 15. 5 goes into 20 4 times. 4 times 12 is 48. 20 times 1 is 20. And then this will be minus 3 times 12 is 36. And it'd be over 20, but it would cancel with the 20. So this is like that 20 distributes through. All right, little fraction's gone. 63 over 20 minus 36 is -16. Now, real quick, our sine of alpha plus beta was -63/65. Our cosine of alpha plus beta was 16/65. And then the sine over the cosine is -63/16. I mean, it is the same alpha and beta through all of this, so we should see that pattern. Part of me is just like, why did I work out the formula? And, well, it's just as well. We got to use it on D. So It is literally going to be everything I wrote there. Like all the number parts. This will be a minus, and then down here, this will be a plus. Again, though, I am still going to do e times 20 over 20, because I don't want to actually figure out what 3/4 minus 12/5 is, but 15 minus 48 over 20 plus 36. I'm just cheating by copying the numbers I just had up there. So we got 56 on the bottom, so this guy might actually reduce. Let's see, 38 minus 5, negative 33. Nope, doesn't reduce. 56 is 7 times 8, 33 is 3 times 11, nothing in common. All right. So, it's a very silly practice, but if we ask you to do one of these problems, you look up the formula, you plug in the numbers, you do the thing. A lot of math is about being able to follow a set of steps, follow a procedure. It's very boring and tedious, absolutely. All right. So now we got a really weird one. We have an identity. Yay! Last one of the section. All right, so we're just going to fill in what they are. So sine of alpha plus beta plus sine of alpha minus beta is apparently going to equal 2 times sine alpha cosine beta. All right, we'll deal with that. We're going to start with the left side because while it doesn't look bad, I can write the formulas for each of those guys. Plus, that was the whole point of this section, so we should probably start there. All right, so our sine was sine cosine plus cosine sine, and then plus sine of alpha minus beta. So it's going to do the same thing. Sine alpha cosine beta minus cosine alpha sine beta. And oh, look at this. They cancel. And oh, look at this. It's the same thing twice. 2 sine alpha cosine beta. Oh, look, that's what we wanted to prove. Done. All right, so that is 4.2 using our sum and difference formulas. 4.3 is just going to be some more formulas, double angles, which come directly out of these. Find the end button.